Dear students, today I will discuss another misconception, or you can say a confusion among the students. Okay, so the confusion is on the definition of refraction of light, and sometimes I have seen that students are very confused about the definition of refraction of light, and they ask always questions when I am giving a lesson on this refraction of light. And sometimes if students are not aware about this fact, intentionally sometimes I have also raised this question to the students and confused them, and then understand the thing, the discussion will forward, and the discussion will be going on, or the discussion will be ahead. Okay, so the thing is, and the confusion is on the definition of refraction of light, and I have given here two definitions of refraction of light, and I will discuss among these two which one is more appropriate. Okay, so the first definition, you can say I have written over here that when light ray passes from one medium to another medium, it will bend. This phenomenon is called refraction of light. So here the importance is given on the phenomena that the light ray should bend. So this definition signifies that the phenomena of light is called refraction only when the light ray will bend. And according to this definition, if we analyze the cases with the help of this diagram, then we can easily say that this definition is not appropriate, though most of the textbooks write this definition I have seen. According to this definition, when light ray passes from one medium to another medium, it will bend, and this language is well fitted for these two diagram, that when the light ray passes from one medium to another medium, but it will incident obliquely for this case and this case, and the light ray will bend. Sometimes it will bend to the normal, or sometimes away from the normal. But the interesting case is that when the light ray is incident normally to the surface, then no bending will occur. So if this definition is correct or appropriate, then this case cannot be considered as a refraction of light. But in actual case, this is also the refraction of light. But the most interesting thing is that if someone wants to support this definition, as this definition is written in most of the textbooks, so one can support this definition, and to give support to this definition, sometimes students or many people can say that this is not the phenomena of refraction of light, because here Snell's law is not valid. Apparently, you can see that this mu is in the form of 0 by 0, and one can say that here the Snell's law is not valid, but for these two cases Snell's law is well valid. So you can say that this is not the case of refraction of light, and then this definition is appropriate, as these two are the refraction of light, then there is no case of bending of light, etc. But in actual case, this is also the refraction of light, and here also the Snell's law is valid. I will tell. See, this mu is equal to sin I by sin r is not actually the definition of mu. The confusion among the students is based here. They thought sometimes that this is the definition of mu, that is mu is equal to sin I by sin r. But this is a Snell's law. This is the outcome, that if we take the ratio of sin I by sin r, then it will give the result of the refractive index of denser medium with respect to rarer medium, or the rarer medium with respect to denser medium, and if we take it as r, then it is a absolute refractive index. Okay, so in that case mu is equal to sin I by sin r. But this is not the definition of mu actually. The definition of mu, which comes from the Maxwell's equation in electromagnetic theory, is nothing but mu is equal to c by v, where c is the velocity of light in air and v, or in free space, and v is the velocity of light in medium. So mu is equal to c by v is the definition of mu, and it does not depend on the light ray is incident obliquely or normally. So it will remain same for all the cases. But this mu, which comes from Snell's law, is depends on the angle I and R. So it will depend on whether the light is bending or not. Okay. But the interesting case is that as here is normal incidence is occur, then I is equal to 0 as well as R is equal to 0. So mu is equal to sine 0 by sine 0, that is equal to 0 by 0. And sometimes students confuse that here mu is not defined, or this term they consider as infinity. But this is not infinity, or this is not implies that mu is not defined, because this is not the definition of mu. The definition of mu is here, mu is equal to c by v. So this 0 by 0 is nothing but the indeterminate form. That means mu can take any value. We cannot determine mu from this equation. That's why it is called indeterminate form. And here mu can take any value. And which value mu can take, it will depend on this equation, that is mu is equal to c by v. So in that case, in that respect, there is no violation of Snell's law in this case. Or if you write this Snell's law in other way, that mu is equal to 0 by, instead of mu is equal to 0 by 0, if we write it like this, that sin I is equal to mu sin R, suppose sin I is equal to mu sin R, and in that case if I is equal to 0 and R is equal to 0, then 0 is equal to mu into 0. So there is no problem. Some quantity into 0 will always be equal to 0. So you can write Snell's law in this pattern instead of this. If you ignore or if you avoid the mathematical confusion or the mathematical absurd result, if you want to avoid this thing, you can write this as like this: 0 is equal to mu into 0. So there is no problem with Snell's law. So this is actually the phenomena refraction of light. As these are the phenomena of refraction of light, this is also the phenomena of refraction of light. So this definition is not appropriate where it says that the light will bend. But if you investigate the cause why light will bend, the cause of bending of light, if you investigate, then you will get the correct definition or most appropriate definition of refraction of light. And you want to know that the bending of light is due to the change in velocity. And probably I have made another video. I made another video on this context, the why light will bend. Okay, so that is the discussion of another thing. But here it is sufficient to say that the cause of bending of light is just the changing of velocity of light. So if velocity will change, then the light will bend. But it is not necessary that if velocity is changed, the light will bend. The cause of bending of light is changing of velocity. But if velocity is changed, it is not necessary that light will bend. If light will bend, then you can readily say that the velocity is changed. But if light will not bend, then you cannot say that velocity will not change or velocity is not changing. Velocity will change when light enters from one medium to another medium. It will definitely change. But this changing of velocity will deviate the path of ray only when the incident ray is incident on the surface obliquely. But here it is incident normally. So velocity change, but its bending is not occurring over here. But here the velocity, in these two cases, velocity is changed and the bending of light is also occurred. So if we want to consider all the cases as a reflection of light, then you should be take this definition where I have written that when light ray passes from one medium to another medium, its velocity will change. So when light ray enters from one medium to another medium, then if its velocity is changed, then we can call this phenomena as a refraction of light. So I think this is the most appropriate definition of refraction of light, which will solve your all confusion about this phenomenon. Okay, thank you.